this lesson, we are going to discuss simplifying fractions. Our objectives are fairly straightforward. In order to simplify fractions, we got to take it down to its lowest terms. And we'd also like to be able to represent a simplified fraction visually. So before you begin, there are a couple different things you may need. Can you multiply and divide? And do you also know how to write a fraction in an equivalent form using multiplication or division? Those are skills that we will use. For instance, what are 3 equivalent fractions for that? Of course, when we're looking at it, we can start off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looking at them, that would give us 6/10. And we saw with equivalent fractions that we could block this a couple of different ways. For instance, we could look at this, and if we were to split them up into blocks of size 2, oh, that's not what I mean. Come on, that's all right. Come on, settings, stop. All right, my board's glitching. Okay, since my board's glitching, it's not going to let me do that, I'll take this first instead. We could block this with a size of 2, and that would be 1, and 2, 3, a block of 4, and a block of 5. We discussed before that visually what this piece is doing is just dividing out by 2. When you divide out by 2, this would become 3 pieces out of 5. Well, we didn't look at them very much this other way, but another tool that we could have used for these is to, instead of grouping these into bigger chunks, we could have split them up further into smaller pieces. For instance, never mind, it's not going to work for me again. If we split these into 2 pieces so that there are twice as many chunks, we could have created bigger numbers. And when you do it this way, what you're actually doing is multiplying by 2, which would have given us 12/20. The whole point that I'm trying to note with this, you can get the base fraction in yellow just by counting. Then, if you use multiplication or division, you can create equivalent fractions. Recognizing, though, that bigger numbers are more difficult to work with, we'd rather work with smaller numbers. They're just easier. But it is really, really important that we don't actually change what the number is. That's why we spent this time going over equivalent fractions. Equivalent fractions are the same number written in 2 different ways. Well, if we could have them written in a different way with smaller, easier numbers while keeping it the same, that just makes it better. For instance, in order to simplify them, we want smaller numbers. Well, in order to simplify them then, we've got to use division. What number is going to divide into both 7 and 14? Since 7 goes into both of them, we'll divide out by 7. 7 divided by 7 is 1, 14 divided by 7 is 2. That's how we'd simplify. Simplify here. What number goes into both 8 and 12? Okay, 2 is one option. If we divided that out, we would get 4 and 6. And although that's simpler, it's not simplified, because we could still go smaller still. We could divide by a second 2, which gives us even smaller 2/3. And there we're done. very common for students to like the dividing method for simplifying fractions. It's what I see most students using. But I do want to emphasize that this is not the only way that we could have done it. We could also have rewritten 8 over 12. In particular, we could, if you think of just the factor tree, 8 is 4 times 2. And so one thing we could have done is write it up as 4 times 2. 12, if we start using a factor tree, is 6 times 2. And so there's 6 times 2. Anytime you split something up like this, if you've got a top and bottom pair, they cancel. And you'll notice what we have here is the 4 over 6 that we had before. Sometimes students prefer to work it this way. In general, this strategy is really good if you use the entire prime factorization that we worked on before. In particular, grab this, boom. If we split the 4 up into 2 times 2, we could have written this as 2 times 2 times 2 to the top. Our numerator is 8. 6 is 2 times 3, so we could have had 2 times 2 times 3 for our prime factorization in the denominator. And then just cancel out every single pair. 2's cancel, 2's cancel, and you're left with 2 over 3, the exact same thing that we did before. It is possible to simplify fractions with multiplication. It's possible to simplify them with dividing. You could do it either way you want. It's been my experience, most students prefer dividing because then they just take advantage of their calculators. I do want to emphasize though, down the line, when you start working with pre-algebra, you'll have to simplify fractions of monomials. When you get to pre-algebra and you're simplifying fractions of monomials, you will need to use this method in the blue. You would wind up canceling pieces out, so even if it's not your preferred method, it's still a good one to get comfortable with because you will need it down the road. So what do you think? 15 over 20. Do you want to simplify with multiplication or division? If we choose dividing, we'd have to look for a number that divides into both. If you recognize 5, if you can look at the numbers and see that 5 goes into both of them, dividing is a good strategy to use because you can simply divide it out and get 3 over 4. If you don't immediately recognize the 5 though, it can be helpful to split them up. 20 is 2 times 2 times 5, and I got those just by doing a factor tree. 5 times 3, 20 is 4 times 5, so 2 times 2. If you don't immediately see them, sometimes this multiplying method is better because then you could say 5's cancel, and you're left with 3 over 2 times 2. They both work. It's just a matter of preference. And I'll admit, unlike most students, I prefer this dividing method. Less writing. I think it's quicker. I think it's easier for the way my brain is wired. It's the one that I like. So when I look at these, I'm searching for a number that will divide into both 100 and 25. Of course, I recognize that 5 will do it. But I also recognize that 25 will do it also. And so, because I'd rather divide out by bigger numbers, it gets me my answer faster. If you recognize dividing out by 25, you can get your answer much, much more quickly in one step instead of 2. What about here? If you're going to shade them in, how many of the boxes need to be colored? Well, a lot of times people can just quickly visually see that it's going to be 4. If you can get this visually rapidly, that's great. If not, well, you can always count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, and then just simplify the fraction. If you divide out by 2, you get 4 over 5, telling you that 4 out of the 5 should be shaded in. You could do it visually or numerically. And here's our last problem for this video. 15 of the 25 students in your class have Twitter. Write the fraction in simplified form. 15 out of 25. So the base fraction is 15 out of 25. There is our fraction. It's not simplified. So what could we divide by to simplify 15 and 25? We divide out by 5. 15 divided by 5 equals 3. 25 divided by 5 equals 5. And so we have our simplified fraction 3/5. And we're done.